Tutorial number 9, question number 1. Given point C is moving to the right at 0.5 meter per second, and linkage BD has an angular acceleration of 0.5 radian per second square. We need to find the magnitude of the acceleration of point B at the given instant. First, we can do a free body diagram to the linkage BC. So for BC, for point C, it has velocity to the right, which is VC, which is 45 degrees. And also for point B, it has VB, which is 30 degrees, and also VB with respect to C. This one is 45 degree also. Then VB is equal to VC plus VB with respect to C. This is equal to omega BC cross VBC, RBC. The VB sine 30 degrees is equal to VC plus negative omega BC times R BC cosine 45 degrees. Then VB cosine 30 degrees is equal to omega BC times R BC times sine 45 degrees. Then we have 1 over 2 VB is equal to 0.5 minus square root 2 over 2 omega BC square root 3 over 2 VB is equal to square root 2 over 2 omega BC. Then we have VB is equal to 0.366 meter per second, and omega BC is equal to 0.45 radian per second. It's counterclockwise. So we can also do a free body diagram to the linkage BD. At a point D, it has angular acceleration. We call it alpha BD. And also at point B, it has normal acceleration. We call it AB with respect to D. And also tangential acceleration. It is 30 degrees. And VB has the same direction with tangential acceleration. This is also 30 degrees. Then VB is equal to omega BD times RBD. Omega BD is equal to 0.35 over 1 is equal to 0.37 radian per second, counterclockwise. AB is equal to AD plus AB with respect to D, and AD is equal to 0. Then we have AB with respect to D. Tangential direction is equal to alpha BD RBD times sine 30 degrees I plus alpha BD times RBD cosine 30 degrees J. This is equal to 0.25 I plus 0.43 J. And A, B respect to D in normal direction is equal to negative omega BD square R BC cosine 30 degrees I plus omega BD square RBD sine 30 degrees J. This is equal to negative 0.12 I plus 0.07 J. So we can sum this up. We have AB is equal to 0.25 minus 0.12 I plus 0.43 plus 0.07 J. This is equal to 0.13 I plus 0.5 J. The magnitude of it is 0.13 square plus 0.5 square. Square root, this is equal to 0.52 meter per second square. Question number 2. Each of the two uniform cylinder bars OA and BC has a mass of 8 kilograms. The bars are welded at A to form a T-shaped members and are rotating freely about a horizontal axis through O. If the bars has an angular velocity of 4 radians per second as OA passes the horizontal position shown, we need to calculate the total force R supported by the bearing at O. If we take a free body diagram of this whole T-shape members, so we have RT, which is the reaction force in tangential direction, and Rn. And also the gravity for the OA is 8 times 9.81. And also for linkage BC is 8 times 9.81. First, we can calculate the moments of inertia first. Then IO is equal to 1 over 3 ml squared plus 1 over 12 times ml squared plus ml squared. This is equal to 17 over 12 times 8 times 0.5 square kilograms meter square. Around point O, the sum of moment is equal to IO times alpha. Now we have 8 times 9.81 times 0.5 plus 0.25 is equal to 0.5 square times alpha. Now we can get alpha is equal to 20.8 radians per second square. So in tangential direction, we have Ft is equal to sum of MAT. 2 times 8 times 9.81 minus RT is equal to 8 times 0.25 times 20.8 plus 8 times 0.5 times 20.8. Then we have RT is equal to 32.3 Newton. Then in N direction, Rn is equal to 8 times 0.25 times 4 square plus 8 times 0.5 times 4 square is equal to 96 Newton. Then R is equal to square root 32.3 square plus 96 square. This is equal to 101.3 Newton. Question number 3. The uniform steel I-beam has a mass of 300 kilograms and is supported in the vertical plane as shown. Determine the maximum angular velocity reached by the beam as it rotates in the vertical plane about the bearing at O. Also determine the corresponding force R supported by the pin at O for this condition. First, we should draw the free body diagram of this I-beam. We set this as theta. And here's the gravity center, which is 300 times 9.81 Newton. And this is point O. And reaction force is RT and Rn. Then this angle is beta, and if we draw our tangential directions through the gravity center, we will know this is beta and this angle is theta. Beta is equal to 24.2 degrees and IO is equal to 1843 kilograms times meter square, and R is equal to 2.19 meter. If we take the momentum around point O, so moment around O is equal to IO times alpha, then 300 times 9.81 times 2 cosine theta minus 0.9 sine theta is equal to 1843 alpha. Then alpha is equal to 1.597 times 2 cosine theta minus 0.9 sine theta. If we take the integral from 0 to omega, then it's equal to 0 to theta alpha d theta. We can get omega squared over 2 is equal to 1.597. 0 to theta 2 cosine theta minus 0.9 sine theta d theta. Then omega squared is equal to 3.19 times 2 sine theta minus 0.9 1 minus cosine theta. If we take a derivative with the theta, then we have d omega squared d theta is equal to 3.19 times 2 cosine theta minus 0.9 sine theta. X is equal to 0. So theta is equal to tangent 2 over 0.9 inverse is equal to 65.8 degrees, because we need to maximize the omega. Then omega maximum square is equal to 3.19 times 2 sine 65.8 degrees minus 0.9 times 1 minus cosine 65.8 degrees. This is equal to 4.13 radian per second square. Then omega max is equal to 2.03 radian per second. If we take all the force in normal direction, it will be equal to m r omega square. Then we have Rn minus 300 times 9.81 sine 24.2 plus 65.8 degrees is equal to 300 times 2.19 times 4.13. Then Rn is equal to 5660 Newton. In tangential direction, again is equal to mr alpha. You have 300 times 9.81 times cosine 24.2 plus 65.8 minus RT is equal to 300 times 0. Then RT will be 0. Then R is equal to Rn is equal to 5.66 kilonewton.